Dakota, thanks for the question on the force velocity curve. So I've copied your question here just to kind of make it a little bit easier to follow. So an explanation of force velocity curve, and then the relationship between velocity and muscle force. So first, let's kind of focus on drawing the graph. So on the x-axis here, we have velocity, or essentially percent of maximal velocity. So, right, so we'd have 100%, so this would be as fast as you can possibly do the movement, and 0 would, of course, be no movement at all. On the y-axis, we have muscle force. Again, this is a percent maximal, so 100% of your maximal force, above 100% or less. Again, if we kind of think back to what we did in class, and as we discussed, the kind of experiment that we had students do as a demonstration would be kind of like visualize and kind of think about lifting a really low amount of weight. And if you're able to kind of think about that, a low amount of weight, you're able to move at a relatively fast velocity. In other words, if the force in which you must produce is low, we can do that at a really high velocity. On the other end of the spectrum, if we think about something like a 1 rep max, this is, of course, going to be a high amount of force, again, close to your 100% of your muscle force. And then in that situation, your velocity is very, very slow. So if we actually kind of draw the curve here, what we see is that the relationship here on this side of the curve, which are all concentric contractions, is basically an inverse relationship. So that's okay. Let's see if we can try to draw that one a little bit better. Sorry, having to use a laptop to kind of try to draw. So what we get is kind of this upsloping curve. Again, these are situations in which the force in which we're able to do the contraction is all is less than our 1 rep max. So on this side of the curve, right, this is all concentric contractions on the side of the graph. So again, as we kind of look at the relationship here, this is an inverse relationship, right? As velocity goes up, muscle force must go down. Conversely, as muscle force goes up, velocity must go down. And another way that you can think about it, right, is in order to do a very fast contraction, we must do it at a low weight. In order to do a very forceful or a heavy contraction, we must do that at a very slow velocity. If we kind of think about, there is a point where we can hold the weight. We can't actually move the weight during a contraction. We can just hold it, and in that case, that contraction then becomes an isometric contraction. So that isometric contraction can be seen right here, where velocity equals 0 and muscle force equals 100%. So this is our as we move to the other side of the curve, basically what happens is the force is being produced by our muscles, but because it is more than what we can hold or lift, the velocity or the direction of the curve starts going in the wrong direction. And so basically what we see is that eccentric contractions now, again going in the opposite direction, are going to produce more force. So on this side, we can say that this is an eccentric contraction, and they produce about 50% more force than max isometric. As far as this is, you know, kind of an odd-shaped curve, so I don't necessarily expect you to be able to kind of draw the idea of a relationship here. The primary relationship is this inverse relationship between velocity and force. So hopefully that helps.